Welcome back. So today we're going to work on section 4.4, which is the last section before your first test. And this is on inverses of functions, okay? So we're going to start by talking about one-to-one functions first, and then we'll look at inverse functions. All right, so to make something one-to-one, or for a function to be one-to-one, both the graph or the function has to pass. Easiest way I can tell you is that you have to have your graph being able to pass not only the vertical line test, but it also has to pass the horizontal line test. So basically, if you remember about functions, remember all the x's had to be unique and different if you were picking out if it was a functions and the y's could repeat. Well, to be a one-to-one function, the x's can't repeat and the y's cannot repeat. So that means your graph would pass both the vertical and horizontal line test. Then the last two bullets is just telling you that if you have a function that's either always increasing or always decreasing, then it's automatically one-to-one. And in a minute, we're going to be finding inverse functions. So you can't find an inverse of a function unless the original function is one-to-one. Okay, so those are just things about one-to-one functions that you need to know. So the first example is just giving you some pictures of graphs and asking you to ask if these are one-to-one functions. Okay. So remember, to be a function, it has to pass the horizontal line test, which means the vertical line test, which means your vertical line can't cross the graph more than one place. So now, to be one-to-one, it also has to pass the horizontal line test. So this graph, it's a cubic function, so it definitely passes the vertical line test. But if you draw a horizontal line anywhere through it, it's still only going to cross the graph once. So this is a one-to-one function, okay? It is. All right, if you look at the absolute value function, it passes the vertical line test, but it does not pass the horizontal line test. So this would be a function that's not one-to-one, okay? All right, look at the next one. Vertical line test is fine. This is a function. Horizontal line test, is that fine? Yes, it is, because even right through here, it's only going to cross your graph once, right? That's an open circle. So this one is one-to-one. And I just use the number 1 instead of writing out one-to-one like that. So either way is okay. All right, here we have just points. It is a function because if you draw a vertical line anywhere, it's only going to cross those points once. But right here, it's going to fail the horizontal line test. It's going to cross 2, so that is not one-to-one. Okay? All right, so now, can you think of other functions that would be one-to-one or not, other than these up here? So the first one is, let's sketch something that is one-to-one. Well, think about all your parent functions that you had. I'll give you a couple. So the first one I can think of is your square root function. That is definitely one-to-one. Another one-to-one function would be the rational function that goes like this, right? That's also one-to-one. So there are, plenty of functions that are one-to-one. Okay? A function that's not up here that is not one-to-one, the most famous of all would be the parabola, right? X squared. That is not one-to-one. Okay? All right. So this next part asks you if these functions have inverses. You're more than welcome to graph these on your calculator, or if you know a little bit about them, that's all you need to know. So 3x minus 7 is a straight line, which keeps increasing like that. So this is one-to-one, okay? And if they are one-to-one, then they would have an inverse. So I'm going to check the ones that work. So that does have an inverse. All right, this is a radical. So I know what the parent function looks like. But this one goes right 3 and up 2, so it's still one-to-one, right? Looks like that. Oop, sorry, up 2. Be there. Okay, but regardless, it passes the horizontal and vertical line, so this would have an inverse. All right, 3 over x squared. Remember, your rational functions that are x squared kind of both are in the top. So it's a function, but it's not one-to-one, so we could not find the inverse of that function, nope. And then cubic functions, you might just need to graph it, but this one, because it has that middle part, is going to kind of go like that. So it would also fail the horizontal line test, so we can't find the inverse of that. So just the top two are the only ones that we would be able to have an inverse of. Okay? So if you know if they're one-to-one, then you'll know if you can find the inverse. All right, so now we're going to move on to finding the inverses and a little bit about them. So if a function is one-to-one, then it will have an inverse function. And this is the notation for inverse functions. That's not f to the negative 1 power. You can't raise a function, a letter to a number. This is just the notation for inverse. So you read that f inverse of x, okay? If a function is not one-to-one, it may be possible to restrict the domain so that the restricted function is one-to-one. So I'm going to go back and explain that real quick. Remember our x squared function? That's not one-to-one, but in a couple of these problems, it's going to say that use x squared, but only when x is greater than 1. So if you only use part of it, then you can use that. So that's what that is talking about. So you have to pay attention to the domain they give you, okay? These are the steps to finding the inverse, which I know all of you have done somewhere along the way. We will do these in a minute. So there's 4 steps. You're going to replace the f of x with y. Remember, you're going to switch all the x's and y's around, solve for the new y, and then you'll have your new inverse function. So you'll replace the y with the inverse notation. So we'll do those in a minute. Then remember, since you're just switching the x and the y's, then the domain of the regular function will be the range of the inverse, and the range of the original function will be the domain. So they just switch, because all we're doing with inverses is switching x and y around. That's it, okay? The last thing to note is that the graph of any one-to-one function and its inverse are symmetric to the line y equals x. So I'll show you that on the next page with one of our examples, okay, where that is. All right, so these are just numbers to make sure you understand the notation. So if I ask you to find that this is function f, and this is asking you to find the inverse of function f. So all that means is you're going to switch the x and the y's. You don't change the signs, you just switch the x and the y's around. So I'm looking at each ordered pair and I'm flipping the x and the y's. Okay, I'm not changing any signs, that is the inverse. So if you're asked to find a function value on the inverse, well, this is the inverse function, so this is x on the inverse function, so this would be your answer. If you don't have that listed, then if this is the x on the inverse function, that means it's the y on the original function, right? So you can look at it either way you want to. What is the domain of the inverse function? The domain would just be the x values, -2, -5, 0, and 8. Okay, just the x values, which remember, that would be the range of the original function. They just switch. So don't make this harder than it is, okay? All right, so this next example shows you about that last piece about the graph being symmetric to the line y equals x. Okay, so let's look at, here's just a small piece of a function, and we want to graph the inverse. So this is the line y equals x. It goes through the origin, it goes through 1, 1, 2, 2, right? So it's just that diagonal line. So I'm going to write these points here. So this is -4, -2. This is -3, 1. This is -1, 2. And this would be 1, 4, right? All right, so if we're going to graph the inverse, we're just going to flip these around. So we're going to plot the point -2, -4. -2, 1, 2, 3, 4. Okay, there's -2, -4. We're going to plot 1, -3. 1, 2, 3. 1, -3. We're going to plot 2, -1. And then we're going to plot 4, 1. Okay, and if we connect those, you'll see that this is the line of symmetry. If you fold your paper diagonally, these are going to be symmetrical, right? If I turn it like this, it's easier to see. There's the line. So look, those are symmetric over that line. Okay, so that's what that part means. So if you're asked to graph, pick some points, flip them around, and that would give you the inverse. Okay? All right, example 7, we're going to find the domain and range of the function, the domain, and then find the inverse. So these are good problems. I like to go over these with you because you don't have to do these in the order that they're given, okay? So, you know, hopefully by now you can find the domain of any function. We've been working on that. But we don't know the range without looking at the graph. Well, maybe I don't want a graph and I don't want to do that. So here's what I'm going to show you. So first off, I know the domain of this is all real numbers. Remember, x to the 1/5 power is the 5th root, right? And remember, the domain for all odd radicals is all real numbers. All right, so if I know the domain of the function, it is automatically the range of the inverse. Okay? Those have to be true because you're flipping the x and the y's around. What I don't know is the range of this. I don't really know what that looks like without graphing it. Okay, so what I can do is find the inverse function and then I can get my answers. So if I find the inverse, so let's start with, and I'm just going to leave it as the 5th root. I think that might make sense for most of you guys. All right, so step 1, going back to these 4 steps, okay, I'm going to number them. So step 1 is to replace the f of x with y. Step 2 is to interchange, replace the x with y's and the y's with x's. Okay. Step 3 is to solve for y. So to solve for y, I would subtract the 1 over first, and then I would raise both sides to the 5th power. To get rid of the 5th root, you would raise this to the 5th, so you would also raise that to the 5th. So we end up with x minus 1 to the 5th equals y. And then step 4, I'll put it over here, is simply to replace y with function notation. So the inverse would be x minus 1 to the 5th, okay? All right, so this is the inverse function of this function right here. All right, so now I know this is a polynomial to the 5th power, so I know the domain of this, which is all real numbers of any polynomial. So that automatically means the range of that is all real numbers. So you can kind of do these in any order that you want to help you with figuring out domains and ranges. All right, now here's a good example of that restricted domain. So this is a parabola. That would not be 1 to 1, but they're telling us we can only go from x is greater than or equal to 0. So this is a parabola that went up 3. So it kind of looks like that part of the parabola. So I already know the domain. X has to be greater than or equal to 0, which means that's the range of this. Okay? Now, look at the range of this. I can do this because I know this. The range goes from 3 to positive infinity, which means the domain has to go from 3 to positive infinity. Okay? They have to be the same. So now let's look at that and see what the inverse is. Now I know, think about math and your functions. When you square something, to undo it, you would take the square root. So I know that the inverse function for this is going to be a square root function. I just got to figure out what it is, okay? So we're going to take the function and do our 4 steps. So 1 is to replace the f of x with y. 2 is to interchange the x for y and the y for x's. And then we're going to solve for y. So subtract 3 over to this side. And then we're going to take the square root of both sides to undo y squared. And then step 4 is to write it in function notation. So we're going to replace y with the inverse. We get x minus 3. So there's your inverse. Okay. Now look at that graph. The square root of x minus 3 is the square root function, and you're going to go right 3. So we're going to go 1, 2, 3, right there. Okay, so there's the inverse, and look at that. There's your imaginary line, and that is the line of symmetry for those. And the domain of that is definitely from 3 to infinity. Okay, so it works out nicely. So that's kind of a good thing. Okay. All right. All right, let's look at one more example of a radical with a restricted domain, okay? All right, so we have this domain, all numbers less than or equal to 1. So that means our domain is going to be from negative infinity to 1 like that, right? All right, so this is kind of an interesting graph. So remember our transformations and what happens. This might be one because of that minus sign in there that you might want to graph it just to make sure you're okay. And remember, I'm fine with that. So if you put in the square root of 1 minus x, and then get out of the radical and plus 2, I know it's going to reflect, but you know, you might be thinking, I'm not real sure. All right, so look, it reflected over the y-axis because remember the x was negative. We went right 1 and then plus 2. Well, actually, we went left 1, but when we flipped it, it went back. Okay, so there's the graph. So that's why I have to have my x less than or equal to 1, right? Okay, so let's just look at that. So that's the point 1, 2. It's kind of like that. We're just sketching it on there. So just kind of, so we have it. All right, so now we can look at the range. The range would go from 2 up to infinity, right? All right, so now I know the domain of this has to be 2 to infinity, and I know the range negative infinity to 1. All right, so let's find the inverse and let's see if that's true. So write your function down, do your 4 steps. So step 1, replace the f of x with y. Step 2, switch your x and your y's around. And now we're going to solve for y, step 3. So the first thing I'm going to do is subtract the 2 over here. Now to undo the radical, we're going to square both sides. So that gives me x minus 2 squared equals 1 minus y. All right, so now I'm going to go ahead and bring the y over here to make it positive. Leave that 1 there, and then I'm going to bring this whole term over here to make it negative. You can do it any way you want to. That's just kind of the easiest thing. You always want your y to be positive. So I move the y over, which means I had to move that over there. The 1 could stay where it was. All right, so step 4 is to just change that with your inverse function notation. So that equals 1 minus x minus 2 squared. All right, so if we look at this, remember, this is a parabola, okay, that goes right 2, up 1, and then this reflects over the, when it's on the outside, remember that reflects over the x-axis, okay? So if we look at that graph, let's put it in here with this one, okay? So 1 minus parentheses x minus 2 squared, graph that. All right, now remember, we're only doing, our domain had to go from 2 to infinity. So we're just going to start right here at 2, just kind of right here, and we're going to do that, right? Just that side of the graph, that's all we can use. Remember, this is not 1 to 1 here, so we only got part of it. Well, again, look at your graph. Here's your imaginary line of symmetry. And again, those are symmetric to one another, as best I could draw that. Okay. So there's your inverse function, and then there's all your answers. So, you don't have to draw the graph if you don't want to. It's totally up to you. It's just kind of to help you see that that's an inverse. All right. I think I'm going to stop here and do part 2. Again, the video is getting close to 20 minutes, so I'm going to pause, and then we'll do part 2. So if you want to work on some homework, take a break and come back, and we'll fill in the rest of the notes on the next part.